All right, CNT125, we're working on Chapter 7. We're on the section on cloud computing. They remind us that the internet is frequently pictured as a cloud. Okay. Well, nowadays, cloud computing is a lot more usable, functional, popular, used a lot more. So therefore, the cloud actually has a heck of a lot more meaning than it used to. So, cloud computing, this is literally, as they define it, flexible provision of data storage application services to multiple clients over a network. Yeah, with this, there is all kinds of computing that is available to be used by a cloud provider, storage that's available, and hosting. And I threw a couple examples here to kind of get you thinking. With cloud storage, things like Dropbox, OneDrive, Google Drive are all examples of cloud storage. Cloud hosting, web-based email systems like Gmail are all part of this as well. So all of these things are available from cloud providers, and they're there to provide those services to you. So let's start looking at what they're doing. First off, some of the big players in the game are these guys. Amazon Web Services, Rackspace, Google, IBM, Smart Cloud, Microsoft Azure. These are some of the big players right now in the cloud computing realm. And I also like to remind you guys, if you do a ping of something like hack.edu, what you find is it's going to respond with blah, 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 AmazonWebServices.com. The hack website is being hosted by Amazon Web Services. So there's a kind of down-home example of cloud computing where our hack homepage is being hosted by Amazon Web Services. Here are some of the big players again, your Amazons, Microsofts, Google, that sort of thing, Rackspace. If I look at, and again, I'm not really hung up on the numbers here too much, but just giving an idea who the big players are, and this is towards the end of, actually say middle of 2018, so just a little while ago, you see kind of the growth in the market share. These are some of the big players here in this part of the graphic here, Amazon, Microsoft, Google, that sort of thing. In addition, here is current and planned usage of public cloud. Again, 2018, you see Amazon Web Services, Azure, Google Cloud, IBM, etc. So again, some of the big players in the game. Just tuck them in the back of your brain. Those are some of the big names that are out there right now. Well, your cloud service providers, most of them use virtualization software to supply multiple platforms to multiple vendors. Okay, let's start putting this into place, if you will. So if you have somebody like a hack that's going to host their website, they're going to contract, as we saw back here a little bit ago, with somebody like Amazon Web Services to say, hey, we would like you to host our website for us. Well, Amazon Web Services is going to have a physical server somewhere in the world that hack is going to put their website on. They're going to slice that physical server into a couple slots, and they might have, I'm just going to use examples here. They might have Penn State Harrisburg's website on one virtual machine on the server, and on the next virtual machine would be Hack's website. So on that physical server might actually be 2 or 3 different websites of different companies or organizations. It's very possible. So your cloud computing companies are going to use virtualization to create these virtual machines for different customers for different purposes. Absolutely. That's why these two topics get tied together. As we were building our virtual machines earlier this semester, we're kind of building the first piece of a bigger system. That virtual machine could be allocated to a certain function or a certain client for that matter. So Rackspace, Amazon Web Services might use their virtualization to allocate to different customers. Absolutely. Okay. Cloud computing distinguishing features. It's kind of a self-service on-demand thing. Because it's being hosted out there, it's not reliant on my network being up and running as long as the provider is. So it's kind of self-service. As long as people can hit that, it's there. It's there and it's available for them. It's elastic. Most of these services can be programmed that let's say again we're hosting the Hack homepage on Amazon Web Services. That Amazon Web Services server can be programmed that at peak demand, it actually allocates more memory. It even allocates more processing to that website, to that web server to meet that demand. And at 2 and 3 in the morning, kind of spool that back and say, I don't need that much processing and memory on that website. So it can actually grow and shrink based on need, and that can be programmed into it. Your cloud computer can support multiple different platforms. Again, those servers, I can gen up a virtual machine that's running Apache web server as well as an IIS Microsoft web server, depending on the need of the customer. Not a problem. Can support multiple platforms. Resource pooling consolidation, yep. Metered service, yep. Again, we kind of mentioned on some of that, mentioned some of those things earlier. So here, showing multiple different devices hitting a virtual server that might be providing one or above, one or all of those to clients or a client or clients. It can actually provide virtual desktops to people, and this is becoming more popular, or I should say more usable and popular for places where I don't need the robust desktops in many office environments, so I just have a small computer there that they get their desktop from the cloud service provider, or the cloud server, if you will, and they get their desktop from there and use that, a virtualized environment. Developers can load all kinds of software on the service and test it from afar. Absolutely. I could load maybe a new database or a new website or web server we're going to do onto the cloud provided server for us, work with for a while and go, yeah, okay, we'll use that. Or no, we don't want to use that. Clear it off and start over. Maybe you make it a test case kind of thing. Absolutely. Developmental purposes. If I have to categorize cloud computing, they actually do a couple different things. These traditional infrastructure as a service and so forth. So there's a couple different categories for cloud computing. The first one is the traditional model. Traditional is where the customer literally has all the hardware, all the gear, all the applications, all the operating systems, all the equipment, and does it all on their own. So they have all of their own networking, routers, switches, data storage, servers, actual physical servers. They might even virtualize their own servers in their network. They have their own operating systems they put on. They have their own data storage. They have their own applications, etc. The whole shebang is done by the customer and customer IT crew, if you will. Well, some places start subscribing to infrastructure as a service. Infrastructure as a service, then part of that is now contracted out to the cloud provider. Again, somebody like a Rackspace or Amazon Web Services. We contact them, make a contract that says, you know what, I want you to give me a web server that we can put our web page on. So they actually provide for you the actual networking, the routers and switches and things to get to it, the actual storage in the server. It might be a virtual server, but the storage in the server, and gen up the base operating system for you, and you take it from there. And you start putting all the web page on and the data that you need on it, etc., and then you maintain it and run it. That would be your infrastructure as a service. And they even show you down here, customer use vendor service to store data, host websites, provide email, that sort of thing. So now the IT crew just simply maintains that server. Everything else, the contract, whether it be Amazon or Rackspace or whoever, does that for you. The platform as a service takes it one tiny step further, where again the provider is doing more work for you. Each step you go up, the provider is doing more work for you. Now, platform as a service, the provider does all of that plus a little bit more. So in this case, they might actually provide the full running access database for you, and you just simply put the data on and maintain it from there. So they have it all up and ready to rock and roll for you. You just put the data on, key the entries in, storage of parts and warehouse data, etc., that sort of thing, and then you maintain it from there. The software as a service is pretty much the top of the heap. Now the provider's doing pretty much everything and you're just consuming. So you're just paying for the final product, if you will. This would be something like a Gmail, Google Drive, that sort of thing. You are just simply, they provide it all for you. And again, you could contract that. If you're a small business, you could contract to a provider to say, we want you to do the email for us. We want you to do the phone server for us. We're just going to key in the phone numbers. We're just going to key in the names, that sort of thing. And they provide all of that for you. That's your software as a service. And then they do, sometimes you run into this mention as well, XaaS, anything as a service. And this might be a combination of things not previously mentioned. This, piece of this, piece of that kind of thing. You might see that listed, so just kind of tuck that in the back of your brain. But those are traditionally the four models you see. Infrastructure as a service, they provide this much. Platform as a service, a little bit more. Software as a service, pretty much the whole shebang. So you kind of see that growing, going up in the how much they provide for you and do for you. And here they even try to show you that just that it's like, okay, infrastructure as a service, just some this kind of things are done. Platform as a service, these kind of things are done. Software as a service, pretty much these kind of things are done. You're just subscribing to the final product, if you will. And even here, a lot of times you might have network architects doing this, where it's just like, hey, we just need you to provide A, B, and C. We'll do the rest from there. Application developers doing this is like, okay, we need the running server. We'll run it from there. And then software as a service would be the end users. Maybe the clients in a small company need the whole email server maintained. We just want to use the email service, if you will. So showing kind of the ownership going up the ladder there. Deployment models, they have different types of deployment models for this. Public cloud, this would be examples like your Gmail and that sort of thing. Public can use this. Using over public transmission lines, I can get to my Google Drive, I can get my Gmail, that sort of thing. Private cloud is we're just doing it in-house for us. We maintain our own virtual service for people to access through our company. A community might be a actual service provided between hospitals, or you have a large hospital organization area, and the doctor's offices and area feed into that hospital. A certain blah 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 medical system. All the little doctor's offices feed into that. They would have access to all the same data and servers, and there might be a database between those doctor's offices and that hospital in that area. And hybrid would be a mixture of, hey, we use the public cloud for this for email, but we use this private server in-house and blah. Kind of a mixture of to get the job done. Drawback, they give you a pretty large list, potential risks and limitations depending on the type of cloud you're doing. The ISP is your limitation. Bandwidth limitations in your ISP, yep. How good is the cloud provider's uptime, backup, and security systems, yep. Misconfigurations that might expose problems or connection issues, yeah. Unauthorized access, yep. Breaches of confidentiality in agreements, yes. Depending on what you're storing on there. Data security regulations, again, depending on what you're storing on there. Who owns what's on there, when you start talking pictures and the kind of email data that's in there, the data that's in those emails, who is owning that, who's maintaining what, and what kind of work payment and work time and that sort of thing, repair time. Risk to your network caused by devices brought in by users and or employees or students, kind of thing. Confidence in some of this because of problems that have occurred. These are all potential drawbacks. So with that, your cloud providers often offer attractive SLAs, service level agreements. And this, they start delineating levels of internet connection, levels of, amount of time for repairs, that sort of thing, in these different areas. Internet, remote activity connection, lease lines, dedicated connections. I jumped ahead of myself. Your cloud providers usually offer pretty good service level agreements for all of this. Now, your WAN link can actually play an important piece of that. If you're using just the internet, it's cheap and easy, but you might have some of these problems that are mentioned about latency and so forth. If you have a lease line, That's going to be a little bit better for connection, but it's going to be a little more costly. Dedication will be the highest cost. So thinking back to your WAN chapter previously, this plays into your cloud connections. All right, we'll continue on with the next topic in the next podcast.